This is the summary for Lesson 6, Strategic Solving. And what the authors would like you to do is look at the structure of how this is set up. But the first thing they're going to do is get rid of this 6 because they identify that there are variables on each side, that this is pretty tough to look at. Variables on each side, parentheses, fraction. So what are you going to do? How are you going to start to solve this? And they notice that here you multiply by 3 and then you divide by 6. And they say that's the same as dividing by 2. Well, that's not so obvious. Why is that the same as dividing by 2? Multiplying by 3, dividing by 6. Well, 3/6 is equal to 1/2. So 3/6 simplifies to 1/2. And then it becomes clear that 2x minus 20 is then divided by that 2. So I'm going to work that out just a little bit. So I like, rather than divided by 2, I like to think of it as multiplying by 1/2. I like using the multiplicative inverse. I like just using multiplication and addition rather than division and subtraction. So multiply by 1/2. So 3/6 simplifies to 1/2, and I've taken here, this is the 2x plus a negative 20. So 2x plus a negative 20. So I change this to addition, and the additive inverse of a positive 20 is that negative 20. And then this 3/6 simplifies to 1/2. So now this is written as 1/2 of this amount. And 1/2 of this amount is the same as taking 2x plus a negative 20 and dividing it by 2. So it's down here, 2x, and I change this to plus a negative 20 divided by 2. So this right here is the same as this expression right here. Now the steps to get from here to here, you can separate that out a little bit more and realize that dividing by 6 is the same as multiplying by the multiplicative inverse. So what's the multiplicative inverse of 6 is 1/6. So rather than divide by 6, I can multiply all of this by 1/6. So 1/6 times 3 times this 3 times 2x minus 20. I left this as minus 20. So divide by 6 is the same as multiplying by 1/6. So multiply by the multiplicative inverse. So 1/6 of 3 is 3/6, or 1/2. So 1/6 of 3 is equal to 1/2. There are 6 1/2s in 3. So this becomes 3/6, and then that can simplify to 1/2. It just takes practice. Just have to keep going through getting used to simplifying fractions. I think it's useful to look at the multiplicative inverse. Remember, dividing by 6 is the same as multiplying by 1/6, the multiplicative inverse of 6. Just takes a lot of practice to go through this. All right. So I ended up with 1/2 times 2x plus a negative 20. That's this right here. And this is the same as this expression right here. And so now x plus a negative 2. So I'm going to change this to adding a negative 2. So I'm going to distribute negative 2 to x plus 5. And this becomes 1/2 of 2 is x, and 1/2 of a negative 20 is negative 10. So this becomes x plus negative 10. And that's written right here. 1/2 times 2 is 1. So this becomes 1x, and 1/2 times negative 20 is negative 10. All right, so I'm going to take this part right here and write this on the next page. So the authors and I are going to do this a little bit differently. The authors are going to keep this as subtraction, and I'm going to change this to addition of a negative 2 times this amount. And what they want you to see is that both the left and the right side are being subtracted from x, the way the authors did it. So this amount right here, this 2 times x plus 5, is being subtracted from x. Well, this 10 is also being subtracted from that same x. Well, that means that this amount right here has to be equal to 10. These two sides have to be equal because x is equal. And if I'm taking something away from x, whatever I'm taking away from x on both sides has to be equal. Now I'm writing it as addition. So whatever I'm adding to x, I'm adding an amount to x right here, and I'm also adding a negative 10 to x right here. That means that this amount right here, negative 2 times x plus 5, has to equal negative 10. They have to be equal. Now, a way to think about this, I think this makes it clearer, maybe not, just a different way to think about it. Think about this part of the equation as a, and think about this part of the equation as b. So now I have x minus a equals x minus b. Well, what does that tell you about a and b? It means that they have to be equal to each other. Now, this may be where I complicate things a little bit by changing it to addition. We'll go through it. X minus a equals x minus b. That's the same as x plus a negative a equals x plus a negative b. So now I'm adding an amount to x, and I'm adding the same amount to x. In this case, it's a negative a. In this case, it's a negative b. But they are equal to each other, so negative a has to equal negative b. Well, if the opposite of a equals the opposite of b, that means that a has to equal b. I don't know if this helps or not. It's just another way, because this can be a little bit much to look at. So if you just replace it with a single variable, it might make things easier for you. All right, so now we're down to 2x plus 5 equals 10. So they're looking at this part right here. 2 times x plus 5 equals 10. And I'm going to look at it as a negative 2 times x plus 5 equals negative 10. So negative 2 times x plus 5 equals negative 10. So the authors are keeping this as a positive value here, a positive value, and I changed it to a negative value because I'm adding a negative value in the original equation. All right, so if I write this down here, the same thing, negative 2 times x plus 5 equals negative 10. So I'm going to use the distributive property. So I'm going to distribute that negative 2 to this x. So it's a negative 2x. And I'm going to distribute that negative 2 to this 5. So it's a negative 2 times a positive 5. So the opposite of 2 times 5 is 10. The opposite of 2 times 5 is negative 10. So here I have an amount, negative 2x plus negative 10 equals negative 10. I'm adding an amount to negative 10, and I'm getting negative 10 as an answer. That means that this negative 2x has to equal 0. It can't be anything else. I can't add a positive amount. I have to get negative 10. So if I add anything other than 0 to negative 10, I will not get negative 10. So negative 2x has to equal 0. So negative 2x equals 0. Now, if I add 10 to this side of the equation, and if I add 10 here, I'm going to end up with negative 2x equals 0. So 0 plus negative 10 equals negative 10. That means that this negative 2x has to equal 0. And a negative 1/2 times negative 2 means that this, you get rid of this coefficient, this becomes x, but a negative 1/2 times 0 is 0. So x ends up equaling 0. So I did this a little bit differently. I used the distributive property, whereas on the left side, the authors divided by 2, and they're left with x plus 5 equals 5. And then if you subtract 5 from each side, you're left with x equals 0. So they're doing a little bit differently. Now, something that's a little bit confusing in how they describe this is they say up here, well, the 2 and the 5 multiplied together are 10. So that means that the 2 and the x multiplied together cannot have a positive or negative value. So what they're saying there is they're talking about this 2 times this 5. This 2 times that 5 equals 10. Well, this side is equal to 10. So 2 times 5 is 10. That gives you the 10 on the left side. So whatever you multiply 2 by for x, that has to equal 0. Because 0 plus this 10 that you get from this 2 times 5, you can't get anything else. You can't add anything to the 10. You can't subtract anything from the 10 because 10 has to equal 10. So that means that 2x has to equal 0, so this x has to equal 0. If x is 0, 2 times 0 is 0, 0 plus 5 equals 5 in this case. A little bit confusing. I had to think for a while, what do they mean here? 2 and 5 multiplied together are 10. This 2 and this 5.